flowing into the case in the case of in this front fan. So the arrow direction is this way, and I'm going to set it into place and use some of the fan screws that came with the case in order to secure it. Okay, all the 4 screws are now securing the front fan to the case, and I'll snap the back fan into the bracket. Now again, I want to look for the directional arrow. In this case, I want to make sure that the air is blowing out the back of the case. So that would be this direction. And since this fan has, this case has a nice bracket, I can simply click the fan into place into the bracket. Okay, the fans are secure. Now you would run the cables to the motherboard, plug them in. Like so. Later on I'll worry about dressing the cables, that is, making sure they're out of the way of any other components and things like that. At this point I'm just getting them plugged in. Okay, now we're ready to install the disk drives. Now I'm going to mount 4 disk drives here and then an optical drive up here. I'm going to start by mounting the hard disk drives. Now I'm going to take my first drive. Now I mentioned in another segment that these drives came with the limiting jumper installed. That is, these are 3 gigabit per second drives, but they came with a 1.5 gigabit per second limiting jumper in place. So I'm going to remove the jumpers from these drives. Now, I'm going to use a little tool to help me extract that jumper. They're very tiny little jumpers. You might want to save them just in case you need them again if you are going to install these drives in a system that doesn't support the 3 gigabit per second operation. Okay, now those jumpers are removed. Now we're going to do a mount of these drives in place. Okay. And you want to slide it until the screw holes line up and then begin inserting the screws. So what I'm going to do is I'm going to slide all of these drives into place and install all the screws, and then we'll see what it looks like when it's complete. Okay, there's the last screw for the hard drives. I've now got 4 hard drives mounted and 1 optical drive, and I used 2 screws on either side of the drives, which mounts them very securely and also makes the case more rigid and improves thermal transfer between the drives in the case. So anyway, those are all mounted. Now I need to cable up the drives, and then I can finish install the power supply. Now all of these drives are SATA drives, so I've got 4 cables for the hard drives, and I've got 1 extra cable for the optical drive. So they are going to plug in here. Now this motherboard has these side-mounted SATA ports, which I don't really like. I prefer them to be, plug in straight from the top. But this is how a lot of them are. Good thing that the back panel comes off of this case, because it makes getting to this a lot easier. So I'm basically going to connect the 4 hard drives and then the optical drive cable. So I'll start with the first one here. Get all these cables plugged in, and then we'll connect them up to the drives. There, I've got the last cable plugged in. All the drives are now connected to the SATA ports on the motherboard, as is the optical drive up here. As you can see, again, being able to remove the back side of the case really helps with routing these cables, getting them out of the way. It's going to make for a very neat appearance on the front side and very clean routing. So now, at this point, I need to install the power supply. So that's going to be next. Now, in order to do that, we have to lay the system down, get my power supply, which I have here. I'm going to be using a 510 watt PC power and cooling supply. And I'm going to set it into the case. Make sure I've got it the right orientation. And get it to line up with the screw holes, and then I will put in the screws. Okay, the power supply is now secure. Now at this point, I've got to route all these power supply cables. And it's easiest to do that with the system laying down. Now I'm going to need to plug in the main power, which, whoops, I have right here. I have the CPU power. I've got auxiliary power, let's see, 4 video cards, which is over here. And I've got the drive power. So I'm going to go ahead and get all these connected up, and then we'll see what that looks like. Okay, there. At this point, I've connected all of the power to all of the disk drives, including the hard drives and the optical drive. I snapped the front cover plate back on the system and ran the front panel USB and audio connectors to the motherboard. You can see those here. Here's the USB connection, the front panel connection. Now that was made a whole lot easier because I had replaced those multiple little pin, connectors with a single individual connector. The USB was a single individual connector, and the audio, the front panel audio, was a single, individual connector, not a bunch of little tiny pins that you had to try to get on there. Also, I used my trusty zip ties to tie up some of the cables to keep them away from the motherboard. I like to have everything as open, as clear as possible, unobstructed airflow through the system. As you can see, the wiring turned out, very nice and neat. A lot of it is kind of hidden on the other side here. Here's the hard drive and optical serial ATA cables, and here's where the front panel cables came in through the case. So it's so nice to be able to take this back panel off and be able to route the wires like this. Okay, now at this point, we only have one thing left to do, and that's to install the video card. So that's going to basically go into the number 1 PCI Express X16 slot right here. So all I have to do is remove the card bracket holder from the back of the PC here and pop the card into its slot. Now, well, let me first get that screw out of there. Take that off. Okay, now I wanted to make a point about this video card. I mean, I like a high-powered video card as much as anybody, but I can't stand the noise and failure-prone small fans. A lot of video cards have small fans on them, and they very easily clog up and are very failure-prone. So this is what's called a passive heatsink cooled video card. It has a heatsink on it, but it uses no fan. So it relies on the cooling in the system to pull enough airflow over this to keep it cool. Now, because it is a no-fan video card, it doesn't require extra power. So although this power supply had extra, PCI Express video power connectors, it could, drive a very high-powered video card. This will not need that. So basically, all I'm going to do now is install the card in the slot. Now, as you can see, I've removed the bracket from the slot here, so the back of the machine, so I can line this card up with the slot, make sure it goes in straight, and pop it into place. Now once it's installed, I can then lock it down with the card holder here. Okay, so now the video card is secure, and basically at this point the system is complete. All I have left to do now is to put the side covers on, the front and back side cover, and hook up the power. Then basically I would run the BIOS setup, set up the RAID array through the Intel BIOS, and then begin loading my operating system. So this PC is pretty much ready to go. In this segment, we're going to install the processor into the motherboard, the heatsink onto the processor, and then we're also going to install the RAM. Now, installing the processor and heatsink is probably the most difficult single part of building a PC for the novice person. But it doesn't really need to be that difficult. You'll see exactly how it's done here, and I'll give you some tips and tricks along the way to make it easy and a little less intimidating. Now, the one problem with this is that in most situations, when you go to install the processor and RAM, the motherboard already has to be mounted in the system. You can't really install the processor and the heatsink with the motherboard out of the system because you have to put a lot of pressure, and particularly when you install the heatsink, and it's normally the best if the motherboard is already installed. Well, that's where in the other segments I've talked about having a chassis that uses a removable motherboard tray, because that means you can install the processor and heatsink and memory with the motherboard essentially out of the system without the confines of the case around you, making it difficult to see what you're doing and get your hands in there and everything like that. Well, I've saved trays, motherboard trays from cases that I've discarded just for the purpose of installing processors, heatsinks, and RAM to make it easy. Then once all of this is installed, I can then load the motherboard into the chassis with everything ready to go. So at this point, if you don't have a removable motherboard tray, you'll have to install the motherboard first into the chassis, then complete these steps that we're going to do here. So now we're going to install the processor. This motherboard happens to have a socket LGA 1366. That stands for Land Grid Array 1366 pins. Now what that means is that the pins are actually in the socket, not on the processor. If I take, for example, the processor looks like this. It comes with a protective cover over the back of it, and if I take that cover off, it just snaps off. You can actually see the lands on the back of the chip. Now these are just basically gold spots, gold contacts. There's no more pins. Older processors or other processors in some cases use individual pins there instead of the lands. In this design, the pins are actually in the socket. Now in order to get this ready to be installed, I have to remove the tension on the load plate, and what we have here is called the load lever, which presses down on the plate that will eventually hold the processor in the system. So I'm going to move this lever over to the side, lift up what's called the load lever, and then I'm going to lift up the load plate, and now I'm going to remove the plastic protector that comes in the motherboard. This protector protects all the tiny little pins which are in the socket. There's, as I said before, 1,366 fine, very tiny pins in the socket, and you do not want to touch them. Just the slightest touch, snag it with a little bit of cloth, something like that, will bend those pins and basically render the motherboard destroyed. And when you go to turn it in for a warranty repair, they will look at that. And if they see that the pins were bent, you may have a problem collecting on that warranty. So now, with the load plate lifted up, we are ready to actually drop the processor in. Now, if you take a look at the processor, you'll see that it has notches on either side, and they're offset, to one end. And those notches have to align with special indents on the side of the socket. So basically, take a look at the socket and look at where those indents are, and drop the processor into place. There you go. Now the processor is set into the socket. However, there's still no tension on it. In order to have it fully installed, we need to drop the load plate on top of it and then kind of press it down a little bit and use this load lever to put all of the tension on it, and then put the lever underneath the retaining tab on the side. So at this point, the processor is now installed in the socket. The load plate is putting pressure onto the top of the processor so that all of the lands on the bottom are in contact with all of the pins in the socket. So it's as you can see, it's fairly simple and straightforward to install a processor. Now, if the processor is of the type that uses pins, it works very much the same way. You don't have a load plate, but you do have a lever which releases tension on what's called a zero insertion force socket. Then you drop the processor into the socket, observing the correct orientation, and then you basically close the zero insertion force lever, which then applies pressure to all of the individual pins. So whether it's a pin processor or a land grid array processor like this one, the installation is very similar. Okay, now, with the processor installed, we have to deal with the heatsink. Now let's talk about heatsinks for a second. I have here the heatsink that came with this processor. Now, heatsinks are made out of usually either two materials, sometimes both. They're made out of either copper or aluminum, and this particular heatsink has both. It has a core of copper surrounded by fins of aluminum. Now, why the different materials? Well, copper is one of the best thermal conducting metals that there is. Silver is a little bit better than copper. It's like 5% better as a thermal conductor, but it costs 80 times more, so we don't usually see solid silver heat sinks. However, a solid copper heat sink would really be the best design. It would conduct the second most heat next to silver away from the processor. So why don't we see heat sinks that are all copper? Well, the problem is copper is expensive. It's a lot more expensive than aluminum. It has twice the thermal conductivity of aluminum, but it also costs from 3 to 9 times more, depending upon whether you're going by weight or volume. So the compromise is that many heatsink manufacturers, what they'll do is they'll have a copper core, like you see on this one, and then surround it with fins made out of aluminum. Some, depending upon the performance nature of the heatsink, some heatsinks might be all aluminum, or some might be all copper. In any case, that's the different types of metals that you'll see. Now, in addition to talking about that, we need to talk about what's called the thermal interface material. That's the material that basically has to go between the processor and the heatsink. Now, the thermal interface material is basically a grease or a wax type substance that make sure that that there's no little tiny air gaps, that the maximum amount of heat is transferred from the top of the processor to the heatsink. If you don't use the thermal interface material, you're compromising the performance of the heatsink dramatically. And what that'll cause is that in many cases the processor will overheat or not be able to run at its full speed, because modern processors don't actually overheat to the point of destruction or stopping. What they'll do is throttle themselves down. So you'll end up with a system that for some reason doesn't seem to be running as fast as it should be. The real reason is, you don't have a good bond between the heatsink and the top of the processor. Now, thermal interface materials come in two main types. One is called a phase change material. The other is called a grease. Now, phase change material is a wax type substance that is a solid at room temperature and which then melts at somewhere over 113 degrees. So when the processor warms up, this stuff will melt and then liquefy and perform as it should. When companies like Intel and AMD deliver their boxed processors with the factory included heatsink, what they will do to minimize, to make the installation as easy as possible, they will pre-apply a phase change type thermal interface material to the bottom of the heatsink. I'm going to show you an example on the screen right now of what that looks like. As you can see in this example, there's like 3 bands of material, and it's a waxy type material. You don't want to touch it. You want to keep it protected until you actually install it, because you can damage it, with your finger. Once the processor is first powered up, that stuff will melt and then it will ooze to where it covers the entire top of the processor. Now, with any thermal interface material, once you remove the heatsink, you have to take that thermal interface material and discard it. It has to be cleaned off. Usually you can clean it off with a paper towel. You can also, sometimes you need alcohol to help dissolve all of it. You want to clean it off the top of the processor and the bottom of the heatsink. every time you reinstall a heatsink, you need to use new thermal interface material. And since as an individual, I can't really get the phase change stuff. That's the only way you get that is pre-applied. We have to use what's called a thermal grease. Now, thermal grease usually comes in packages like this. Here's a package of what's called Arctic Silver, and this is enough for probably hundreds of applications. I couldn't, there's enough in here to install 100 heat sinks on 100 processors. Sometimes when you buy a heatsink, it will include a small amount of thermal interface material like this, a small little, this is good for, maybe 1 or 2 applications. They just give you enough that you can get it properly installed at least one time. Now, this stuff is a grease. Now, what are the differences between that phase change material and the grease? Well, the grease has a couple of problems that the phase change material doesn't have. One is called pump out and the other is called dry out. Now, pump out refers to the fact that as the processor, as the heatsink sits on top of the processor, there is slight movement due to just different thermal coefficients of expansion and contraction, vibration, and eventually this movement kind of pushes the grease out. It kind of extrudes, it oozes out from between. So eventually, there's not an insufficient amount in there. The other thing that happens is it dries out. The grease has like a silicone, usually oil, to suspend the thermal material, and eventually it can dry out. So those are some of the drawbacks of the grease, and that's why the manufacturers like to use the phase change material. Now, I've had people buy, processors that come with heat sinks and scrape the phase change material off, never even using it, thinking that the grease is better. Either one, performs pretty much the same thermally. In fact, I've seen numerous tests of, hundreds of different types of thermal interface material, and rarely see more than a 1 degree difference in the actual operating temperature of the processor, depending upon the different materials. It's just, it doesn't really matter. So people always ask me, what kind do you recommend? Do you recommend the Arctic Silver or, something else? I recommend whatever you have. Just use whatever you have. As long as it's properly applied, it's going to work properly. So in this case, we've removed, I had already installed this heatsink once and had removed it. So now I need to reapply the thermal interface material to this processor. Now, in order to do that, I usually like to use a plastic or rubber glove in order to smooth the material out. So I'm going to put that on here. And I'm going to use this Arctic Silver material. And you're basically just going to put a blob of the stuff on the top of the processor. Not a whole lot, actually. Okay, now, once that's there, you want to use the glove and basically kind of smooth it out to where it covers most of the top of this heat spreader. Now, even if you don't get all of it, the entire heat spreader covered completely, it will ooze, around, especially as the force of the heatsink is applied on top of it. So, okay. As you can see, I've got this stuff pretty well smeared over the top of the heat spreader. Now I can take the glove off. Don't need that anymore. And we can actually install the heatsink on top of the processor. Now, Intel heatsinks are noted by these 4 push-pin retainers, and they have arrows on them that, what's kind of funny is that when you install the heatsink, the arrows have to be turned, or the knobs, the top of these retainers have to be turned the opposite way of the arrow. So I'm making sure that all those are turned in the right direction. It's a common mistake that people look at that and see the arrow and think, oh, well, I have to turn it. That's actually for the removal of the heatsink. So make sure these are all with the proper orientation. And then what we can do is set the heatsink down on top of the processor, aligning these 4 push pins with the holes in the motherboard. Make sure they're all there. And then what we have to do is we're going to have to use a lot of force to push these pins down and lock them in place. Now, that's another reason why having the board out of the system in a tray like this is a big advantage, because I can get my hands in there easier to apply the right amount of pressure. I like to do it on opposite corners. You basically push down until you hear them click into place. And then I'll do these 2 corners until they lock into place. And then take a look around, make sure that all of them look the same and that they're all fully seated. These are. Now once the heatsink is installed, you want to connect the fan, which is right here, and plug that into the CPU fan connector. Most modern processor heatsinks use what's called a 4-wire pulse width modulated fan. And what that fourth wire does is basically it enables an infinitely variable fan speed control. So when you first turn it on, it'll start out slow, it'll spin very slowly. As the processor heats up or warms up, the fan will run faster and faster in order to maintain the proper cooling. So, as you can see, installing the processor and heatsink in this type of a motherboard is not that difficult. That's ready to go. Now, to finish this up, let's install the memory, the RAM in this system. Now, the memory is going to be installed in these sockets here. Now, this uses a triple channel memory, so we were installing memory modules in groups of 3. And you can see 2 different sets of 3 sockets here. There are there's 3 white sockets and 3 blue ones. Now, according to the manual for this motherboard, it says we need to use the white sockets first. That's the first channel, and then first set or bank, and then the blue sockets are the second. So since we only have 3 modules, we're going to install them in the white sockets. So I'm going to move these retaining tabs out to the side on the white sockets. Then I can get my memory module and make sure that the notch on the module is lined up with the notch in the socket. And then I can basically set it into place and then apply sufficient pressure straight down until it locks into place. Make sure these tabs are fully engaged and it's all the way seated down. Then I can go on to the next one, same thing. Press down until it's firmly seated. Make sure these tabs are locked into place. And then finally the last one. And again, make sure they're all in place. You might want to take a closer look, make sure that all the modules do seem to be fully seated. We don't want them on an angle at all. If a module is partially installed and you power the system on, you risk burning the modules and damaging the motherboard as well. So, at this point now, I have the processor and heatsink installed, I have the memory installed. I can now take the motherboard out of this tray and then install the fully loaded motherboard into the system. Now I'm ready to install the motherboard in the case. Now, in order to do that, first thing I need to do is make sure that I've got all the proper screw hole positions. What we have here is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 standoffs or mounts in the case that match the 9 holes on the motherboard. Now in some cases you'll find motherboards that require screws in different positions. You'll notice some extra drilled holes here, and usually the little bag of screws that come with the motherboard will provide extra standoffs like this one that you can screw in if you need the support in those areas. Now make sure that they match the holes in the motherboard. So in this case, the existing 9 holes are exactly what's correct for this board. So with that taken care of, the other thing I need to attend to is the I/O plate that's mounted on the back here. This is the I/O shield, they call it. Now the case comes with one here, but this one doesn't fit your motherboard. So you're going to basically have to break this out. And it's usually just, there we go, piece of thin metal. Take that out, and then you need the one that comes with your motherboard. And what you're going to need to do is to press that into place inside the case. So secure it in the proper position, and okay, I've got a little bit of a problem here. This fan bracket is actually in my way. I'm going to have to take it out. Okay, with the fan bracket out of the way, I can now successfully mount the I/O shield. It basically just sets in the opening here, then you kind of push it into place until it kind of clicks in. So it should kind of snap into place. Sometimes it can be a little tricky, but see if we can't get this one in here. Okay, now I've got the I/O shield successfully mounted in the case, and I'm ready to actually install the motherboard. So to do this best, it's easiest if you lay the case down and basically kind of